They had emergency contractors in here probably within a week or two after. So first the building official has to come in and walk, and they walked in that same day, and they were here for a lot of the aftershocks.
I was, I guess you could say, boots on the ground the day of the Magna earthquake. I was visiting this building to observe damage, actually between the main shock and the aftershock is when we came in the building with the state building official. This whole area was covered in plaster.
The layers of complexity, the sheer number of people involved in the project.
We worked with geoseismic hazards experts to kind of determine what is this type of earthquake that would hit this building. With their help, we were able to build a computer model of this building and we're able to evaluate kind of the weak spots of the building. The earthquake kind of showed us what the weak spots are.
Our task primarily is to work with the structural engineer to get the seismic upgrade installed, and as part of that we have to remove finishes on the inside of the building to install the seismic upgrade, and then we have to tell the contractor how to put everything back so that the building appears the same way that it did.
That's why we brought in CRSA. CRSA, those architects, John Umanowski specifically, this is their bread and butter. This is what they've been doing for their careers. So I rely heavily on them for their research into the materials that were originally used.
This project is a seismic upgrade project, so the goal of this project is to basically reinforce the structure so that when there's another earthquake, it will be able to withstand an earthquake and not get damaged like it did in the last earthquake.
Yeah, it's a lot different working with a historic building than a non-historic existing building. Mainly keeping the finishes intact, keeping character-defining features intact at the end of construction. We like to imagine that at the end of the seismic retrofit, the average person walking in the building won't even know that there was a seismic retrofit. The historic structure report is kind of a accepted format for a report on the existing conditions and the historic significance of a building, and then it kind of serves as the framework for the project moving forward. So, for instance, with the Rio Grande Depot, we started really by investigating the history of the building, its construction, and then also basically inventorying what is in the building and what is historic of the existing features. And then you kind of take that as a jumping off point for how you're going to treat those features during the construction project.
So I'd say kind of the big one is the grand lobby. This is where a majority of the work is going to happen. This is a very tall, very large space, and so there's a lot of reinforcing that has to happen in this area, because when there's an earthquake, this is the part of the building that's going to move the most. And so the north and the south wall is going to get a very large layer of shotcrete, which is just concrete that gets sprayed onto the existing masonry structure. And so part of, I'd say the biggest portion of the historic preservation is putting back the north and the south wall the exact way, to look the exact same way that it did before construction, because all it's going to have to get removed to give us access to the structure so that we can install the upgrade, and then we have to replace the finishes and make it look just like it did in 1910.
Well, one of the major kind of design guidelines that we established was that we're going to affect the exterior of the building basically as little as possible, and throughout the whole design process that has meant that it's pretty much going to be untouched.
The intent of the seismic upgrade is, if we do it right, you shouldn't really be able to see any of the work that we've done, and that's kind of the intent, especially with a historic project. We don't really want that. We want people to walk in here and still have the feeling like they're walking into the building like it would have been in 1910. With an existing building, we can do all these upgrades and things like that, and sometimes it doesn't really matter that you can see those upgrades. But with a historic project, we really want to be sensitive to the historic finishes throughout the building, and we want to make sure that we preserve the building so that future generations can experience the building the same way that we did and older and past generations have done.
So for this one, it was really, we collected a lot of
good historic photographs. We did research at the state archives where there's some Henry Schlacks was the original architect. He had a lot of correspondence with the train company. So it's just really like casting a wide net for a bunch of different research and then collating that into a report and then saying how we're going to respond to that research architecturally.
This space was the Rio Grande Cafe. It was a very popular spot for a lot of years. And we're working on bringing it back so that it can still be a cafe space or however it ends up being used. But a lot of character defining features in here that we're working to protect, like the wood wainscot, the ceilings. We'll be taking down the acoustic tiles, but otherwise some of the details in the ceilings, the bar itself is historic, so we just want to bring it back and make sure we're protecting those historic features.
So this is the ladder up to the attic, and it's very scary. But occasionally when we have to go up and look at the roof in the attic space, we've got to climb this ladder 50 feet up into the air to get up into the attics to take a look around. So we try to not go up here as often, but sometimes we have to based on what we're trying to look at.
Yeah, so in the wings, one of the large parts of our retrofit is we're going to shotcrete the wing walls between 8 to 10 inches in various spots. But we want to keep the historic window casing and trim. So we're actually, before abatement or before construction starts at all, we're working on pulling these off and marking them and packaging together, and then we'll be reinstalling them on the same window. So you can see here, they're kind of in the process of dismantling this one, and then on this window, it's already been disassembled, and this is what it looks like when it's on the ground ready to be packaged. So they'll just wrap it all up and mark it. So this is kind of what the finished product will look like during construction while it's being stored.
So this is where they did the flat jack test. And so basically what they did is they came in here and they raked out some of the mortar, and then they inserted basically a testing device that's kind of like, it's kind of like 2 sheets of paper, and they slide it in there, and the basically it starts to push both ways, and then they basically they just go do that until there's a failure in the material.
There's a lot of layers of complexity. Being that it's old, we don't know how this was put together way back when, so there's a lot of investigation and exploratory work that typically doesn't go on in other projects.
One of the keys with these historic retrofits is to know the nature of the material that you're dealing with. As Jared had mentioned, the codes that we work with actually require us to do testing on the material. You can kind of see here, it looks like there was maybe a compression test or a shear test done here on the brick. Those are 2 important properties that we need to know so we can determine how good is this brick, how much load can it take, items like that. The other item that I mentioned was kind of this mortar. After doing some testing on this mortar, we were able to determine that it was this lime mortar, which is an older type of mortar that really just doesn't have a ton of tensile capacity. So that kind of led us to believe, we're going to have to add in reinforced concrete here to strengthen this brick.
Once you get into the work that we're doing, having those drawings are priceless. They save a lot of time and effort. We did not have really any record drawings on this building. So it required, as one of the very first things in the renovation, a very lengthy and difficult and challenging survey and discovery process where we had specialty consultant on board that was coming in and documenting, okay, helping us understand how this building was built. So that right away was the biggest challenge, not having any drawings available and having to recreate on paper what this building actually is.
Yeah, that's a good point. The architectural team did a good job of doing some reconnaissance. We received historic photos of actually when they were building it, so that was super fun. And you could see we were actually counting number of lights, bricks that make up the composition of the walls. There was also letters that were found that documented the foundation construction, which was super fun to see. The engineer back in, I think it was like 1890 when this was constructed. I can't remember the exact date. But there's letters with the original engineer where there was kind of some cowboys out here building it.
That crack right there that Austin was talking about, that's right where the ceiling and the roof of the north wing tie into that wall. So that north wing is imparting a lot of force into the wall right there, right where that crack. If you were to have asked me before the earthquake, where would the forces become manifest? That's right where I would have pointed. I think we're going to look back on this at some point in the future. And I was just now talking with the superintendent over construction. The Magna earthquake really threw into sharp relief the vulnerabilities on a building like this. I think it's going to be viewed as a blessing in disguise. I think we might look back on it and we might ultimately say, you know what, the Magna earthquake saved that building, because not only did it reveal all of the weaknesses that we're dealing with structurally, but just this morning, these electrical issues that I was not aware of. You know, things like that are all now coming to the surface, and we're able to get all of these things fixed in a manner that's going to enable this building to be here for at least another 100 years. The one thing that I think is really cool about this particular building and the way it responded to the earthquake is what I would call textbook behaviors. The earthquake epicenter is almost directly west of where we are right now. So you would expect that the motion would be in the east-west direction. Sure enough, as you look at the damage, you see the walls that are running east-west are the ones that have expressed all of that damage. Here, the south end of the Grand Hall, that's exactly what you see. The north end of the Grand Hall, that's exactly what you see. But these east and west walls, you look at them, and by comparison, not nearly as much. So, you know, I take a lot of comfort in being able to look at a building like this and just say, you know what, the methods of evaluation and the tools that we have, yeah, they're pretty good. This behaved exactly like we would have expected it to behave. This is another one of the places where we have an east-west wall, so it sustained a lot of damage from the in-plane forces of the earthquake coming into it. It's a masonry wall. I mean, it's solid, but it's got this plaster coating. It's just a rubbed finish, and then they're able to put coatings, you know, paint over that. But all of this will be stripped off, and unless I'm mistaken, at this location is where we'll have new concrete shear walls. That's right. It'll be cast against, actually sprayed against that existing brick. And so this wall will grow another 6 inches toward the interior. It's the natural thing to do. I got to get out of this building. But as we saw with the falling plaster, that was probably a bigger risk than him just sitting here and taking cover. You know, what they teach you in elementary school, get under the desk, was probably the best thing to do, because the more likely hazard is something falling on you. You know, most earthquakes we see are pretty small, and they're not big enough that they're going to cause a collapse of the building, but they are big enough to make things fall.
There's less damage up here. The main brick that fell was actually in the grand lobby, but you can see this is kind of the large swaths of brick that we're going to be putting concrete up against to grab the brick and make sure it's stable. You can see too up on the roof that concrete is actually tested really poorly. It's about a quarter of the strength of kind of modern concrete. So we're taking that into account when we retrofit this.
Above the grand lobby, there are walls that are just like this, but they have collapsed, some of them entirely.
When I look at historic projects by age of building, this is probably the youngest historic project I've ever been on. But where it's been, we're over a year into it at this point, coming up on 2 years, and we still haven't even started construction. It's a surgical job, you know, with all the investigation and exploratory, and then changing directions on how we thought we were going to support it, and then going from micropiles to slab foundation. That's a total 180.
These are like the footings
That's right.
of the building.
Yeah.
Is it weird that I can see them in the basement? Shouldn't think of below a basement?
Well, it's a good point. So one of our main retrofit schemes was originally in modern construction, like you had mentioned, typically put the footings below the slab from grade, and they're kind of hidden from sight. And these actually extend about 2 feet based on what we understand. We did a little bit of testing, 2 feet below, but you can see there's probably 4 feet of the start of the foundation above grade. And this was kind of the idea that we came up with. Originally, we were putting the foundations below the 2 feet, but you can imagine to do that work, you're gonna have to temporarily support this column, which is dangerous. So after talking with the state and the architect, everybody kind of knew that this basement wasn't as critical to be maintained for the historic nature of the building. So we're kind of matching the similar historic foundations of our new foundations that we're going to put in here will be up high. So it will eliminate some of the complexities of having to support the existing structure while also resisting the earthquake forces that we're designing for.
Well, it's really, I guess, a singular experience to be able to work on historically significant buildings like this. And the one thing that I find particularly gratifying, you know, this building's been around 100 years, and with the efforts that are afoot right now, we'll introduce the kind of strengths and reinforcements that are necessary to enable it to withstand a big earthquake. You know, it'll be here for another 100 years and probably beyond. And it's really gratifying to be able to work on these kind of projects, to think that long after we're all gone, this building is still going to be here, providing its service and function as it is intended to.